Hey, this is Brock Ramirez, and in this video I'm going to talk about lab number 4 on math operations in C and the Electron Calculator. All right, so the objective of this lab is for you to gain experience using the built-in math operations in C. And by built-in, what I'm talking about is not the ones that you can add in by including other header files. There's a header file called math.h that we'll get to later. I'm talking about the basic math operations like plus, minus, divide, and multiply, okay? And so when you go through this, what your outcomes are going to be is you're going to be able to show that you can do these built-in operations and also print floating point numbers in scientific format, something we haven't done. And then I want you to think about, you're going to be given a task where I want you to calculate the number of electrons flowing per second for a given amount of electrical current. Now those words might not even register with you, but this is just it's a opportunity to read about some real world engineering phenomena, look at the math that describes it, and then code it in C. You don't necessarily need to understand exactly what's going on, but after you get done with it, you'll have some understanding so that when you cover these things in an electrical engineering class or other classes, you'll be like, oh, I've done that before. Okay, so your deliverables are going to be screenshots of 2 test cases and your Electron Calculator source code. Okay, so let's just briefly, an electron. What is an electron? Okay, so an electron is a fundamental particle that is present in atoms. Okay, so if you think about an atomic structure of material, you have neutrons, protons, and electrons. And if you look at like something like hydrogen, you have 1 electron, 1 neutron, and 1 proton. And the proton and neutron sit in the middle to form the nucleus, and the electron orbits around it. So this is a model of a different atom, aluminum. And the difference between atoms is the number of neutrons, protons, and electrons they have. So you call it the atomic number. Atomic number of 1 is 1 neutron, 1 proton, and 1 electron. That's hydrogen. If you go to 2, that means 2 protons, 2 neutrons, and 2 electrons. That's helium. And if you go up to 13, you've got 13 neutrons, 13 protons, and 13 electrons orbiting. That's aluminum. And that's it. So electron's really cool because it's a fundamental particle, meaning it has mass and it's present in every atom, but it also has a characteristic called charge. And this charge is an additional property, and it can either be positive or negative. And it turns out that if you have a positive charge on a positive charge on something and a negative charge on something, they will attract each other. There will be a force between those 2 particles. And if you have positive and positive, they'll be repelled from each other, and negative will be repelled also. So you actually have the ability using electrical charge to take an object with mass and move it. Okay, so this is like the Force in Star Wars, not touching it, but you're moving it. Okay, and so an electron has this property of charge, but it actually has a specific discrete value of negative 1.602 times 10 to the negative 19 coulombs. So it's a tiny amount of charge. The units are coulombs, and electrons are really small, right? You can't even see them. So electrical current is actually the flow of this charge that we talked about. And we use a lot of electrons to move through a conductor to create current, but it's really about the charge. So it's like how much charge is actually moving through a particular point in time. So we can actually define electrical current as the amount of charge per second that moves past a current point or a specific point. So we define the unit of current as amperes or amps, and that's defined as 1 coulomb of charge moving past a point every 1 second. So now, if you think about electrons having charge of negative 1.602 times 10 to the negative 19, in order to create 1 coulomb of charge per 1 second, that takes a ton of electrons, just an absolute ton. Now, we don't talk about coulombs and number of electrons when we talk about current. We usually say just how much amps are flowing through. And typical values are like, oh, I got 15 amps coming out of my wall outlet. I've got 0.5 amps going down my USB cable. However, in this lab, you are going to actually calculate how many electrons it takes to generate a certain amount of current. Not generate, but are present in a certain amount of current. So the equation looks like this. If you say the number of electrons per 1 coulomb is equal to 1 coulomb divided by the charge of the electron. And the charges, we'll just use the absolute value of it because it doesn't matter if it's positive or negative. So we'll drop the negative sign. But if you just said 1 coulomb divided by 1.602 times 10 to the negative 19 coulombs per electron, your unit would be the number of electrons per coulomb. And this is actually a constant value. It's pretty simple. It's just 1 over 1.602 times 10 to the negative 19th. And it's 6.242 times 10 to the positive 18 electrons per coulomb. So it's a lot. Okay, so now if you look at how you could use that number or use this math in order to figure out how many electrons it takes to constitute a certain amount of current, you could come to this equation. So number of electrons per second equals the current times the number of electrons per 1 coulomb. All right. And then if you want to look at how the units work, current is coulombs per second, and this is number of electrons per coulomb. So basically what happens is the coulombs cancel and you get number of electrons per second. Now, why am I telling you that? It's because you can actually create an electron calculator by saying, I want to take the current, give me the current, and I will calculate the number of electrons per second that are flowing through a given point. Okay. Now, this is pretty straightforward to do. I give you the equations in here, but I want to show you how it looks. First of all, remember, we can print scientific notation using the format specifier %E, and you can still define the precision in this format by using the dot and then a number, which says this is the number of significant digits to the right of the decimal point. Okay. So if I printed something, if I said QE is equal to 1.602 times e to the negative 19, and I printed it in printf using %.4e, I will get something that looks like this. I will get 4 digits to the right of the decimal place, and I will get e to the negative 19. If I wanted the e in this output to be capital, I'd put a capital E there. Okay. So you're basically going to do a simple calculation where the user enters the user's going to enter current and you're going to produce a number of electrons. Okay. So I go through here. I want you to create, as always, create a block header or comment header, include standard IO for printf, the printf function, create the shell for the main. And then I want you to come in here and I want you to create 4 variables of type double. One will hold the charge of an electron. One will hold the current you're going to calculate. One will hold the electrons per current. One will hold electrons per current. Electrons per coulomb, electrons per current. And then you will run the calculations above, okay? When you get done, it will look like this. So let me fire up, let me show you what this is gonna look like. I want you to print out this particular format. Let me get this up here. This, I need enough room. So this is my code right here. So if I look at what's in this directory, I've got electroncalc.c, that's my source code, and then this is the executable. And if I run this, what's going to happen is it'll ask you how much current you have. Welcome to the Electron Calculator. If I come in and I say 15, it'll print out, you entered I equals 1.5 e to the 1 amps, printed in scientific notation, using QE equals 1.602 e to the negative 19 coulombs. There are, and then you will produce this calculation, 6.22422 e to the plus 18 electrons in 1 coulomb. That number is calculated, but it's a good one because you know the answer. It's basically just going to be 1 over QE, and just like we did in the preliminaries, but that'll show that you're actually getting some math to work. Then you basically say there are how many electrons flowing per second in your original current. So this number and this number are going to be variables that you feed in, okay? Then put, that's a lot of electrons. And that is the entirety. So it's really simple. It's just 2 calculations. You can combine them, but don't. Just make it easy for this lab. But that's what your thing's going to look like. And if I can do this for any amount, right? 3 amps, I can do 1 amps, and life is good. You can always check if your program's running by entering 1 amp, and that should give you, there are 6.2422 e to the plus 18 electrons per 1 coulomb. There are the same number of electrons flowing per second in 1 amp. So that's a kind of a check. Okay, when you're all done with that, go ahead and take a screenshot of your output for the test case of 15 amps. Then save it as first name, last name, lab04 test1 JPEG. Then do another test case of 0.5 amps. And you can save these as one file, or you can save them as both files, two separate files. I'll take both of them. And then go ahead and save those in your Windows directory that you created. Secure copy back your source code, upload them to the Brightspace folder, and you are done. All right, that is it. Good luck.